today, guys, now the past 2 days have been review, okay? It's actually not even in our textbook, solving equations, but I think it's a really important skill, and I know it's something that we need a little review on, so I spend time on it. We're actually going to start out more about what's actually in the curriculum for Algebra 2 now, which is you really just start with graphing, and so to begin graphing, we're going to talk about slope. So here's our what, why, and how squared stuff over here, right? We're talking about slope mainly today. Why do we talk about slope in mathematics? Slope is something that kind of tells you how a function is changing, you know? So if it's like you're talking about something that's increasing, like you're making money over time, that's a slope. Speed of a car, you know, that's a slope. It tells you how fast it's changing. So slope is useful for describing how fast things are occurring in mathematics. That's what we use slope for. So hopefully by the end of the day, you guys should be able to find the slope of a function in 3 different ways. I can just give you 2 points. You should be able to find the slope. I should be able to give you a table with data in it, and you should be able to find the slope that way. And I should be able to give you a graph, a picture of a graph, you should be able to find slope. And you did all this in Algebra 1 as well, so it's still review, but technically this is actually part of Algebra 2 curriculum. So, in addition to that, in step 2, you should be able to use your conclusion after you find the slope to tell me if the function is increasing, decreasing, or neither, which you'll understand when we get there. Hey, what's up, man? Yes, thank you for asking. Appreciate it. All right, so I'd like to start off with a kind of like a warm-up, if you will. So this is a linear function. I'm going to give a bonus point to whoever can answer my question, but you got to raise your hand. How do you know that this is a linear function, Vanessa? That's right. Nice job, Vanessa. What's the last name again? Gotcha. Thank you. This is like a warm-up, which is going to give us like pull us into the concept we're talking about today. Yeah. Okay. So now what we learned on Wednesday, I think, was that a linear function is a function where the power is 1. So there is a power, right? It's just they don't write it. Okay. So and as Henry pointed out, y equals mx plus b. That's the really nice way to write a linear function. Now, what we have today that we didn't have for the past 2 days is we have 2 variables. So that's actually how functions work. So we're going to make a table of values here. And what a function is, you guys, is basically it's like two people getting married. You know, they come to an agreement and they decide that, you know, hopefully they'll be faithful to each other and keep their promise, right? So and you know, women have the X chromosome. Are you familiar with that?
The vagina? Oh,
well, that's nice, Henry. I'm glad you had health. I'm so proud of you. Very good. No, they have an X chromosome. You guys familiar with this?
yeah.
And guys have the Y chromosome, so X and Y. So they're married, and here's the guy's promise to the gal. Now we could rewrite this so the girl's making a promise to the guy. We don't want to be sexist, but the way it's written right now, it's kind of written like that. So here's what it is. The guy says to the gal, "No matter what you are, baby, I'll always be twice that plus 5." And he's gonna keep his promise. This is a different culture, okay? Don't laugh at them. That's rude. These are numbers, okay? They have a different culture, all right? They've got to be sensitive, okay? All right. So, for instance, the lady, she swoons a little. Really? What if I'm 1? What if I'm 1? And the guy says, "I promise I will be times 2 plus 5. So what will he be? He'll be 7, right? So if you're not seeing why, I'll show you. She decides she's going to be 1. 2 times 1 is 2. 5 plus 2 is 7. So the guy says, "I'll be 7. I'll always keep my promise." Okay? Then she goes, "Okay, I feel like I can trust you, but maybe one day I'm feeling 2. Maybe I'm feeling like being 2. What's he going to be? 9? You know, they say in the marriage vows a lot of times for better or for worse. That means, like, you know, whenever your spouse is being a jerk, you're going to love them anyway.
Oh,
That's real love. Okay, not saying blue. Okay, you're willing through the bad. So she's like, well, what if one day I'm feeling a little negative? Yeah. What? I'll be right with you. What's what's he gonna be? A little harder. It's harder to get along whenever somebody's negative, isn't it?
-1.
Yes. ladies, Jonathan's available. He is faithful. Even when you're negative, he'll keep the promise. Unless he stole it from Micah, then he's a player and we don't like that.
Whoa, wait, hold on.
All right. One more thing. What if she's 0? What's he gonna be?
5.
Oh, yes.
Okay. So basically, we're just plugging in numbers for x and solving for y, right? Yeah.
Why can't we nowadays have a relationship like these numbers have?
It's faithfulness, man. It's faithfulness. You want to see someone who's a player?
Yes.
My dad.
Okay.
I have nothing to say to that. So it's possible. And so we learn from others' mistakes, and we don't want to make the same one, right? So here's one. This gal, she says, "I'm 4, honey." What's the guy?
I'm 60.
No.
Usually I'm like,
Some negative number.
What would this have to be? What to the second power is 4? 2. Yeah, but you know when she ain't looking, he's -2.
Whoa.
Because -2 squared is also 4. So he's like, got you, girl, be 2. And then when she ain't looking, I'm negative. So, not, and that's what we call a dysfunctional relationship, by the way. This is not a function. When you plug a number in and you get 2 different answers, it's not a function. So that's actual real math. I'm not using the analogy anymore. But it still works in the analogy because you can say it's dysfunctional. But anyway, there it is. So this is what a linear function looks like. Now we're going to graph it. So when you get married, don't you get your wedding pictures? Right? So that's what a graph is. A graph is their wedding picture. It shows you the lifespan of their whole life and the commitment that they've made to one another. So, here we go. You remember that one day when she chose to be 1? What was he?
2.
7.
Wait, I'm not.
He was 7, right? So there's one snapshot of their life, their little album, their story of love. And then we have 2 and 9. So remember when she was 2, he was 9, right? So we're going to 2 and 9. And that one day, which you don't want to remember, but at least they stuck it together. When she was feeling a little negative that day, he was feeling a little bad too. She brought him down, but they stuck it out, right? And then 0, 5, right? 0, 5 would be like right on this line. 1, 2, 3, 4, 5, right here. And how can you tell this has been a faithful relationship? Well, that's encouraging. But more.
From the negative, going
Do you see anybody over here?
no.
No. It's faithful because they're a straight line. Okay? So they kept it on the right path the whole time, right? It's faithful the whole time.
Mine would be like
All right. Beautiful. Their wedding picture. Isn't she pretty? He's
What a
pretty
nice
handsome too.
dog.
Look at that dapper dog. All right. So, but that's graph. Now we're going to talk about graphing next time. You can graph anything this way, plugging numbers, getting answers, but every function you look at, there's shortcuts, because that takes a while, especially when you're telling a wedding story. So, but what I did this for today was to kind of draw some things out for you guys, literally. Here we have this special point. That's what we call the y-intercept. Okay, the place where it touches the y-axis, the y-intercept. What's the y-intercept? What's the y value here?
5.
See it right there? Okay. All right. Now, slope. Can somebody remind me what slope is? Like, raise your hand and tell me. Go ahead, Micah. Good. Okay. Go ahead.
it's right over.
Good. I like both of those answers. Let me let me get these. There's a lot of ways that you could talk about slope, and I'm going to show you a few of the ways. LaFontaine, what's the last name?
Paul.
Thank you. Gotcha. All right. So rise over run is probably the one that sinks in a little bit more. But what Mike said is true also. It's how much the variables are changing at the same time. So let's look at the rise and run first. If I wanted to get from this point to this point, I'd have to go up how far? A different color here. I'd have to go up 2, right? And how far over would I have to go?
1.
1. Now, when you go up, is that a positive direction or a negative direction?
Positive.
So we went up 2 and we went to the right 1. When you're going to the right, is that positive or negative? It's positive also. Which one of these numbers is my rise?
2.
Good. Which one is my run? The slope is 2 over 1. Now, I'm going to take it back to what Micah said, though. It's talking about change, okay? Every time the x changes 1, the y changes 2, okay? Does that make sense? All right, so now, with a linear function, it's not true for other functions, but with a linear function, the slope is the same everywhere. It doesn't matter what you do. So, for instance, let's say instead of trying to go from here to here, let's say that I wanted to go from here to here. Okay, now how far up am I going?
4.
And how far over am I going?
2.
2. What's my rise over run there?
4 over 2.
But isn't that the same thing?
Yeah.
Yeah. So it doesn't matter what 2 points you pick. I could do this one too, by the way. We won't, but we could. And you should still get 2 as a slope. Okay? So what slope is it's something that tells you how fast one variable changes as another one changes. I'd like to spend more time on it and give another story, but I think we better not because time. Okay, so now something I would like to point out is, do you guys remember what happens when a line has this direction? What's negative? The slope is negative. Okay, so you guys remember this stuff from algebra 1. All right. So if it's going down, you have a negative slope, and the reason for that is because every time x goes to the right, which way does y go? Down. And when you're going down, that's a what direction? A negative direction. So you do get a negative slope there. All right. So that's just kind of like a little warm-up to introduce what slope is. Let's go ahead and start writing down some official math notes. So A, what is slope? Is this color okay? Can everybody see it?
Yeah.
Okay. Let me know if you can't. It's a number. That tells you the steepness of a line. The steepness. So the bigger the slope is, the more steep that line is. Okay? Even if it's a big negative number, like -10, that would be really steep, just in the opposite direction. +10 would be really steep in the upward direction. Bless you. Things that are small, like 1/5, that's a small number, right? That's a flat line. They're getting really close to being flatter. So it's steepness, and it also tells you the direction. By direction, I mean positive or negative. Is it going up, or is it going down if you go to the right? All right, so that's what slope is there. The next thing is it's a fraction of how much y changes over how much x changes. This is a relationship between two variables, right? And the point is that they have a contract, an agreement, and as one changes, the other will change with it. They won't necessarily change the same amount, but they'll always have the same agreement. If this one changes this much, that one will always change a certain amount. And that's the slope. All right. Now in math, if I wanted to find out how much something changes, how do we do that? Well, for instance, I used to be 30, and now I'm 38. So pretend you're in second grade right now, and I said, how much did my age change? What's the answer? 8. And so how did you find the answer? You did what? Subtract it. So if you ever want to find how much something changes, you subtract the first and the second one, right? So guess what that gives us? You take your second y and you subtract from it your first y. You take your second x and you subtract from it your first x, and that gives you the slope formula. You guys remember that one? Y2 minus y1 over x2 minus x1. All right. And when y changes, that's what tells you how far up or down it goes. So we call that the rise. You know, if y changed by 3, that means you went up 3. If y changed by -3, that means you went down by 3. And then how much x changes is what we call the run. And so that's why we call it the rise over run. So that is slope. All right, let's talk about another thing, part B. Let's talk about some types of slopes now. You guys hot? Okay, when I get a second, I'll look and see if I can get something done about that. So, don't write what I'm about ready to write. I'm just going to put a dot here and a dot here. Okay, so if I go to the right and up, am I going to get positive or a negative fraction? If you go up, right and up, you're going to get a plus and a plus, right? My outcome will be plus. So lines that do that go that direction. So positive slopes go up, right? So that's what I wanted you guys to kind of connect there. So positive slopes go upwards, okay? Negative slopes, if you start here and end up here, you're going to go right, which is still positive, right? You still have to go right, but then you're going to go down. And when you make a fraction out of a negative and a positive, the outcome's going to be a...
We still have to do.
Sure. You're going to go right and down, correct? So that means I'm going to have a positive on the bottom and a negative on the top. So when you have a negative over a positive and you simplify that, what kind of a number do you get? You get a negative. So when you have this, you get a negative slope. Finally, you can have a constant function . Actually, you know what? Let's erase that word constant. I'm sorry. Put 0. In that case, as you go from left to right, you don't go up or down. It just stays the same. It's a flat line. So functions that go up like this, we call them increasing. Functions that go down like this, we call them decreasing. And functions that don't change because their slope is 0 are called constant functions. Okay, I'll let you guys. So I think the directions, and you guys correct me if I'm wrong, but the directions say something like find the slope and determine if it's increasing, decreasing, or constant, right?
Or undefined.
Or undefined, thank you. All right, so here we go. We didn't talk about undefined. We will in a minute. All right, so what you're going to do, guys, is just pick any 2 points. Now, some of you might already know the answer to this one for the slope. That's fine. You don't have to show work if you know the answer, okay? But for the example, I'm going to go ahead and do it. So what you can do is pick 2 points, okay? Any 2 points. It really doesn't matter. The 2 points that I picked are left 2, down 2. So that's -2, -2, and right 2, down 2. So that's +2, -2. Okay? So that's one skill that people kind of have a hard time with. It's just like remembering how to properly label the coordinates. You want to watch out for that. The x number comes first, the y number comes second. Down and left are negatives, up and right are positives, right? So be careful with that. The next thing you're going to want to do is you're going to want to label these. So I'll give you guys some steps if you want. You don't have to write this if you don't want to, but I'll put pick some points on the line. You're going to want to label them. What do I mean by label them? This is an x value, right? And this is a y value. This is another x value. This is another y value. You're going to call one of the pairs the 1s, and you're going to call the other pair the 2s. And it doesn't matter which one you call the 1s and which one you call the 2s. You'll still get the same answer. Okay? After that, you're going to go ahead and use your slope formula. Does anybody know what the answer to this is without doing the formula? It is 0 because we talked earlier about how it's a flat line, right? We're still going to work it out, but here we go. So my formula is y2 minus y1 over x2 minus x1, right? So I'll put the y's there. You don't have to, but if you think that's helpful to you, you can consider it as well. All right, so what's y2? -2. What's y1? What is x2?
2.
And x1.
-2.
Okay, so notice the double negatives. My formula gives me a minus, right? But then the number I plugged in has a negative on it.
Plus.
So it becomes plus. And what's -2 and 2 make?
0.
0.
Does
They're
it work
opposites.
with the second one too, or the bottom one?
Let's see. These become positive, right? But what's 2 plus 2?
4.
That's 4.
What's
What's
the-
0 divided by 4? That's 0. So that's my slope. So we're going to call that m. That's the letter that we use for slope. It comes from French for monter, which means to go up. Makes sense, right? The m, that's why we use an m. All right, so that's our slope. Now, when you have a slope of 0, look at your notes. What do we call that kind of a function? Is it increasing, decreasing, or constant? Constant. So go ahead and circle your answer. That's it. Not bad, no? So, pick some points, label them, use the slope formula. Cool? All right, so let's have you guys, let's work through one together here. Let's jump down to number 3. All right, this one, why don't we all pick, I'll pick the points, okay? Because if we don't all use the same points, it can be confusing. But really, it doesn't matter which 2 points you pick. All right, so I'm going to pick this one. And I'm going to pick this one. Okay? So the first thing I want you guys to do is label them. Label those points. And I'm going to call on you in a minute to share out your answer.
-2.
Correct? And just so I can spread the points, I'm asking another person. Kiara. Oh, I'm sorry, Kiara. What is the next point? Thank you. 0, -3. All right. Now we're going to label them x1, y1, x2, y2. Alicia, is this an x or a y right here? Yeah, so it's going to be x, y, same thing on your x, y. Let's call these the 1s, and we'll call these the 2s. Okay, the next thing you're going to do is you're going to do your slope formula. So go ahead and do your slope formula and see if you can get your slope. We got to remember the formula first of all, right? y2 minus y1, x2 minus x1. And some of you guys, when I came around, I noticed you had not labeled them as such. So if you don't label them, it makes it a little bit harder, because then you end up with numbers in all kinds of crazy places. So it's really nice if you just start by labeling them up front. All right, now how do you know what the labels are? Well, just remember x comes first, y comes second. It doesn't matter which set you call the 1s and which set you call the 2s. That doesn't matter, but what matters is x is first, y is second. The other big mistake I see is a lot of people are doing x's on the top and y's on the bottom, but it's the other way. It's y's on the top. It's rise over run and y is about up and down, right? All right, so Hannah, what's y2? True, I agree. It's right there, labeled as such. Nelson, what's y1? Good. Adrian, what's x2? 0. Thank you. And then John, what's x1? Uh-huh. What's your last name, John? What? Just another John. Is there another John in here? There's 2 Johns. Okay, cool. So I'm going to come to you next, John, okay? So you can get your point, but I'll get you one too, John. All right, so what did we say this one was? -2, right? All right, so John Chavez, what happens here, man? Okay, so the top, -3 take away 1 is -4. 0 and 2 is 2. Don't forget to simplify, right? -4 over 2 is -2. We're not done because we need to say whether it's increasing, decreasing, or constant. So I'm going to ask Adrian. Where's Adrian? I'm sorry, Adrian. Adrian, increasing, decreasing, or constant? Why is it decreasing? It's a negative slope. So my function is decreasing, and it's sloping down, left to right. Okay. All right, let's do some more. Yeah, we're good. All right, let's do another graph one because we want to do tables also. But it's really the same thing, and I think graphing is harder. So if you know graphs, you're going to get tables. So let's go ahead and do number 4 now. I want you guys to pick. Let's just agree on the points, okay? Because if we don't all do the same points, it's harder for you to understand if you got it wrong. So I'm going to go ahead and choose this point right here, and then I'm going to choose this point. Now this time, instead of walking you guys through it one thing at a time, I'm just going to say do it. Find your slope and give me the final answer, okay? So go ahead and work together. 4 minutes. We got it 40, so there's 7 minutes. If you can do this, you are pretty much equipped to do all the other ones, but I still want to show you a table one just so you feel comfortable when you look at it. It's really the same thing. All right, so you have these, right? So we have y2 minus y1 over x2 minus x1. Now some of you guys got -6 over -1. That's fine too because it's still positive. All right, I want to show you guys a table example before you go. So on your note paper there, let's make a table real quick. This is a table. Same instructions. Find the slope. Do we have 2 y values? Do we have 2 x values? Can you use a slope formula? Same thing. Okay, so it's actually even easier because instead of having to try to figure out what the numbers are, they tell you, right? So in this case, I'll call this one what? y1. We'll call this one y2. I'm going to call this one x1, and this one x2. Formula still works, right? So it's going to be what here? 7 minus y1, which is 1, x2.
4.
9.
Wait a minute, yeah. Oh, 3. Yes, you're right. 7 minus 1? 4 minus 3? Oh, it's the same slope. That's interesting. I didn't do that on purpose. Okay, one more thing. One more example. You guys ready? This one's even easier. Even easier. You guys ready?
It's not even easy. Oh wait, never mind. What?
What's the slope?
2/3.
There you go.
Gosh.
Remember how we talked about at the beginning of class? That number is the slope. So when it's like this, that number is the slope. Okay? So you don't have to do anything else. So that's the easiest.
Wait, if it's so even if it's y equals 2/3x plus 5.
Yeah. It's the number next to the x.
Oh,
Okay? By the way, is this function on number example 2, is that function increasing, decreasing, or constant? How about this one? It's also increasing because it's still positive, right? That's it. We're good for today. You guys can call her a day. If you guys could look down on the floor and look for little scratches like this for me, if you could just kind of pick those up, I'd appreciate it. Even if they're not yours, you don't have to pick up anything nasty or dirty, but just like little pieces of paper, I'd appreciate it. Feel sexy. Thank you for helping. Thank you, dear. All right, guys, week 1 down.
Sir, come back here. Sir, come back here. I know. I was looking back every day. That's the way.